Good day, learners, and you are welcome to MLT channel. This is Engineer Oladipo, your host and your amiable online tutor. Today's subject is physics, and the topic is range of projectile. You are all welcome on board. All right, learners. Without wasting time, let's quickly dive into details. Today, we are interested in range of projectile. So, first thing, let's state the aims of the class. By the end of class, learners should be able to describe range of projectile. They should be able to derive the formula of the range of projectile, and they should be able to apply this formula to solve simple problem involving projectile. All right, so what is range? Range can simply be defined as the horizontal distance covered by the projectile from the point of projection to the point where the projectile is the same level of projection. This can be described in this projectile graph here. The point of projection is actually this point O, where this ball started its journey. As this ball is shot into the air, the distance is covered from point O to the time it returns to point B. This distance OB is actually the range of the projectile, which is represented by capital letter R. That's why they have it here. Range is represented by capital letter R, and since it is distance, its SI unit is meter. Then the formula of range, which is represented by capital letter R, equals to U squared plus sine 2 theta over G, where U is the initial velocity of throw, theta is the angle of projection in degree, while G is the acceleration due to gravity in meter per square seconds. I hope this is clear to you, class. If then, let's move to the next slide, where we shall be looking at how to derive the formula of range of projectile. All right, learners. On this slide, we are deriving the formula of range. So in order to start, we need one of the equation of motion that says that S equal to ut plus half at squared. So this is actually the equation that we shall be using to derive the range of projectile. So let's call this equation 1. Then our S is actually the distance covered by this projectile, but because we are looking for the range, which is the horizontal distance, that implies that we have to resolve the distance covered by this projectile into two components. Actually, the object is projected along from this point of projection O, and it moves along OA. We call it fall to AB. So this distance can be resolved into two. We have the vertical distance, which the maximum height is A, and we also have the horizontal distance along OB. So if we resolve that into vertical and horizontal components, this height will be our SY, which is the distance along the vertical axis, and this our OB will be SX, which is the distance along the horizontal axis. So the resultant of this SY and SX is actually this S. So because we are more interested in range with the distance along the horizontal axis, that implies that our S, which is the resultant of the total distance along both the vertical and the horizontal axis, but in this case now it will be SX because we are only interested in distance along the horizontal components now. Okay, then for our U, which is our initial velocity of throw, here is our U. That's the initial velocity at which the body is moving while projected. So this U, you have to resolve into two components also, because it has initial speed along the vertical axis because the object was moving up. It also has initial speed along the horizontal axis because it's also as it's moving up, it's also covering horizontal distance. So that means we have Uy and Ux. So if you resolve this Ux, which is the initial speed along the horizontal axis, if you resolve it into horizontal components, then our Ux will be equal to U cos theta. If you watch our second video, on component of projectile. We dwell so much on this, and we even derive expression for ux, which is equals to u cos theta. Then our time t, that is the time it takes this projected body to move from point O to point A, because at this point A, that is the maximum height. So the time it takes this object to reach here is, let's call it T max, which is time to reach the maximum height. Then that implies that our T equals to T max. Then the quantity remaining that we need to get expression for now is actually the A. Then for our A, because this object is performing projectile, it has acceleration due to gravity g, because the object is shot into space, is performing both the vertical and horizontal distance. So along the vertical axis, as it's moving from OA, it's moving with g, and the g is negative because it's moving against gravity. As it's moving from, falling from AB, is also moving with gravity, but the g is positive because it's under the influence of gravity. Now along the horizontal axis, the g will be equals to 0, because something that's moving along the horizontal axis is not affected by gravity. So definitely our A will be equals to g, because the body is covering both the vertical and horizontal motion. Then g is 0, because along horizontal component, acceleration due to gravity is 0. We don't talk about gravity when we talk about object that is moving along horizontal component. Then the next thing is now to substitute all these values into the equation 1. Then if we do that, that implies that equation 1 will turn to Sx, because we have already established that our S is equal to Sx. We have established that here. So that implies that this S in equation 1 will now be equals to Sx now. Then also our initial speed of thrown, which is ux, we have also established that our ux equals to u cos theta. So that implies that u here now will be substituted into u cos theta. So we have u cos theta then our t, we have said that t is actually the time to reach the maximum height, T max. So here this t, we substitute for it also, and that become T max. We can just represent by T subscript m, then plus half. Then we have said that our A, acceleration along this will be 0, because our A is equals to g. Why? Because the object is launched into the air. So an object that is launched into the air is affected by gravity. Then that g will be equal to 0, because we are considering the horizontal component of the motion. So that will be multiplied by 0, then multiplied by Tm squared, which is the time to reach the maximum height squared. Then also again, we are trying to get expression for range, and convince yourself that this Sx, which is actually distance covered by the projectile along the horizontal components, is actually the same thing as the range, because we have defined in the previous slide that range is the horizontal distance covered by the projectile from the point of projection to the point where the projectile is the same level of projection. That implies that our Sx now will be equal to the range, which is what we actually want to get expression for. then everything here will become 0, because half multiplied by 0 multiplied by t squared will become 0. So definitely we are going to be left with in the equation that range, because we have said that our s-axis r equal to u cos theta multiplied by, then our time to reach the maximum height is actually u sine theta over g. That is the time it takes this body, this time t is time to reach the maximum height, the time here, and is equals to u sine theta over g. So the next thing now is to simplify this. We have u multiplied by u, and that should give us u squared. Then cos theta multiplied by sine theta, that should give us sine theta cos theta. So therefore our range will now be equal to u squared sine theta cos theta over g. Then from trigonometric identities, sine theta cos theta is equals to sine 2 theta. So that implies that we have to substitute sine 2 theta for sine theta cos theta here. Then if we should do that, our range now becomes u squared sine 2 theta over g, which is actually the formula for the range of a projectile. So this is the formula to calculate the range of a projectile. R equals to u squared sine 2 theta over g. Then it's possible for us to have maximum range, which physicists call R max. So the next question is, at what condition will range be maximum? Range will be maximum when theta is equals to 45 degrees. So substituting 45 degree now in the formula of range for theta, that means R now will be equal to u squared multiplied by sine 2 multiplied by 45 degrees divided by g, and this will be equal to u squared sine 90 degree, because 2 multiplied by 45, that will give us 90, sine 90 degrees over g. This is maximum range, we shouldn't forget that. Then that implies that from trigonometric identities, sine 90 degree equals to 1. So if sine 90 is 1, so therefore maximum range will be equals to u squared over g. and that is the formula to calculate the maximum range of projectile. So learners, before we move away from this slide, we have been able to derive formula for the range of projectile, and we started by using one of the law of equation that says S is equals to ut plus rvt squared, and we have been able to show that range of projectile is equals to u squared sine 2 theta over g. Then range can also be maximum when theta is 45, and we have also proved that maximum range is equals to u squared over g. I hope this is clear to you guys. If then, let's move to the next slide, where we shall look at example on how to apply the formula. Alright learners, so we have an example to try now. Question 1. Calculate the range of a projectile launched with an initial velocity of 20 meters per second at an angle of 15 degrees above the horizontal, and g is equals to 10 meters per square seconds. Alright, that's a very simple question indeed. So identify the problem. We are looking for range. R is unknown. Then what other information do we have in the question? We have the initial speed of throw, u, which is equals to 20 meters per second. Also, we have the angle of inclination, theta, which is equals to 15 degrees. And we've been given g in the question, acceleration due to gravity, which is 10 meters per square seconds. So we shall be using formula method to solve this problem. And in the previous slide, we've learned that the formula of range of projectile is equals to u squared sine 2 theta over g. Now substituting all these values into that equation, so that implies that our range becomes u is 20, that will be 20 squared, then multiply by sine 2 multiplied by 15 degrees over 10, which is the acceleration due to gravity. Then this becomes our range, now becomes 20 squared, that should give us 400. Then multiply by sine 2 times 15, that should give us sine 30 degrees. Then everything over 10. Then 0 cancels 0 here. That implies that we are left with r equal to 40, and sine 30 is actually equals to 0.5 multiplied by 0.5. So finally, the range of this projectile should be equals to 20 meters. I hope this is clear and easy for you guys. If that is true, over to the next slide. Alright learners, so over to the assessment. Let's assess what we've been learning so far. So we have 5 questions here, and question 1, define the range of a projectile. If you have been following what we've been doing so far, you should be able to define the range of a projectile. Then question 2, derive the formula of the range of projectile. That is very important, that you should know that. You could be tested on that in your external exam, such as your WAEC or your NECO. They can ask you to derive the formula. Question 3, when is the range of a projectile said to be maximum? We have said that earlier. At what condition do you think the range of a projectile is maximum? Then on to question 4, which is a calculation-based question. Find the range of a projectile launched with an initial velocity of 15 meters per second at an angle of 60 degrees above the horizontal level. Take g to be 10 meters per second squared. So this is supposed to find the range of a projectile. That is missing. That's a typo error. So projectile should be here. Then the final question for the day, state 2 applications of projectile in sports. Alright learners, I hope you should be able to try all these questions and get them correctly.